Hello students. So we have seen in the previous video what is a triangle and some properties of triangles and different types of triangles and the two important concepts, that is congruent triangles and similar triangles. So let's recall what are congruent figures. Figures are said to be congruent if they have got same size and same shape. Whereas similar figures are those figures which have got same shape but not necessarily same size, isn't it? And we discussed the rules for congruency of triangles. Now in this video we are going to learn similarities of triangles, not exactly in this video, in the upcoming videos. Before getting into similarity of triangles, let's learn a important concept known as BPT, basic proportionality theorem. Basic proportionality theorem. Okay, BPT, also known as Thales theorem. Okay, now before getting into the theorem, let's understand a few things which are required to understand the theorem in a better way. Now, we would have definitely heard this word known as ratio. Now, what does ratio mean? Or for example, if I say 1:2, what does exactly 1:2 mean? It means basically ratio is the thing that is used to compare quantities. Okay, it is used for comparison. So ratio is used for comparison. So if I say 1:2, it means, for example, let's say the chocolates are divided in the ratio 1:2 between me and my friend. The chocolates are divided in the ratio 1:2 between me and my friend. It doesn't mean that I've got one chocolate and the friend has got two chocolates. No, it's not like that. It is comparing, in the sense, if I've got one chocolate, is getting double of me. In the sense, suppose if I'm getting 5 chocolates, then my friend would get how much? Double of me, that is 10 chocolates. So basically ratio is to compare things. Okay, so we are comparing the number of chocolates between me and my friend. So I said my friend, the ratio of chocolates between me and my friend is 1:2, meaning if I get one chocolate, he gets double of me. So if I get 5 chocolates, he gets double of me. Okay, or if I say 1:0.5, if I get one chocolate, it just gets half of it. If I get 10 chocolates, you would get 5 chocolates. So basically ratios are used to compare. Okay, now other word known as proportion. What is proportion? Equal ratios are said to be in proportion. Ratios are said to be in proportion if they are equal. That's it. Meaning, if suppose let's take a ratio A by B and let's take a ratio C by D. If they are equal, if the ratios are equal, then we say the ratios are in proportion. Okay, so this is the meaning of proportion. Okay, few more things that is required. Area of a triangle. How do you find area of a triangle? It is given by half into base into height, isn't it? That is the formula to find the area of the triangle. So let's take a triangle A, B, C. Now, which is the base of this triangle? Most of you would say that BC is the base. Usually base means something which is at the bottom, right? So we get that notion that BC is the base. Okay, it's not necessary that BC has to be base. Okay, just because it is at the bottom, we do not consider this as the base. It can be considered, this can also be considered as base, this can also be considered base. In simple words, out of 3 sides, you take any side as your base. You can take AB as the base, BC as the base, AC as the base. It's just simple. I can just rotate the triangle, right? If I rotate the triangle, this comes down. If I rotate it the other way, AC comes down. So it doesn't matter. You can take any side of the triangle as the base. Doesn't matter. Okay. Now, what is the height of the triangle? If I take, suppose, if I take BC as the base, if I am taking BC as the base, will AB act as the height or AC act as the height? Some of you might think, okay, AB, some might think AC, but some are telling some different answer. What is that? A perpendicular line. Now remember, height cannot be a side of a triangle until unless it's a right angle triangle. We will discuss that later. Now just focus on this. If I'm taking this as the base, then the altitude of the triangle is taken as the height. And what is an altitude? It is a perpendicular line drawn to the side. Let's take this as the side. For this side, from the opposite vertex, that is A, from there, if I draw a perpendicular line, if I drop a line which is perpendicular to this length is known as height. It's very common. It's you can easily understand. Suppose you want to measure your height. How do you stand? You stand straight, isn't it? The angle between you and the ground is 90 degrees, isn't it? That is how we measure height. We don't stand however we wish. Do we stand in a cross way or bending? We are made to stand straight, and the angle between, if you observe, the angle between me and the ground will be 90 degrees, isn't it? So basically height is a perpendicular line. Okay, so I can take this as the base. If this is the base, from the opposite vertex itself, you cannot have the perpendicular from somewhere. This might be a perpendicular, but this is not the height, isn't it? It is from the top to the bottom, right? If you take this is the base, which will be the top? A will be the top, right? So if you want to find the height of me or yourself, what do? You take the tape from top of the head to the bottom, isn't it? We don't start from our hips, right? So in the same way, the perpendicular line should come from the top. Okay, meaning the opposite vertex. Which is the opposite vertex? A. From the opposite vertex, we'll drop a perpendicular. Okay, this perpendicular will act as the height. Now suppose if I take AC as the base, which is the opposite vertex, it is B. From this you should have a perpendicular line. This will act as the height. If I take AC as the base, then B is the height. If I take AB as the base, the opposite vertex is C. From there you will have a perpendicular line that will act as the height. So you can take any side as the base, no problem, but the perpendicular should always come from the opposite vertex. If I take this as the base, which is the opposite vertex, C, from there you should have a perpendicular line. That perpendicular line will act as the height of the triangle. Okay. And there is one special case. Suppose if you have got an obtuse angle triangle. What is an obtuse angle triangle? If it has got an angle which is greater than 90 degree, right? Out of 3 angles, if any one angle is obtuse angle, then you call it as an obtuse angle triangle. Let's take one such triangle. Now, it is very clear that this is greater than 90 degree. Now, suppose if I take this as the base, now from the opposite vertex, I should have a perpendicular. But can I draw a perpendicular? There is no possible way, right? So I have to draw a perpendicular, but I'm not able to draw it. So what I'll do is, I'll draw the perpendicular outside. I'll just extend this base and I'll draw the perpendicular. Okay. This is the perpendicular. So this will act as the height. So what I'm trying to convey is the height of the triangle. Sometimes the line, perpendicular line, can be inside the triangle. Sometimes it can be outside the triangle. Okay. In special cases like in obtuse angle triangle, if you observe, the height is not inside the triangle, it is outside the triangle. This can also be considered as the height of the triangle. But suppose if you take AC as the base, observe, the height will be inside the triangle itself. If you take AC as the base, then I can draw the perpendicular inside the triangle itself. If you are not able to draw the perpendicular inside the triangle, then draw it outside. Till where do you draw it? extend the base. So this will be your reference. So draw till here. So this will be the height of the triangle. The height can be inside or outside. Okay. So these are the important points that you have to know in order to understand the theorem. So let's start with the theorem. Okay, what does the theorem tells us? The statement is, if a line is drawn parallel to one side of a triangle, to intersect other two sides. Let me first write the statement, then I'll explain. Okay, to intersect other two sides at distinct points, then those two sides are divided in the same ratio. Meaning, first let's understand the statement, then we'll go over the proof. Suppose we have got a triangle. Let's take a triangle ABC. Let's take a triangle. If a line is drawn parallel to one side of a triangle, if you draw a line parallel to one side of a triangle, to intersect other two sides at distinct points. Meaning, see, I can also, suppose, let's take this side. If I want to draw a line parallel to this, I can also draw below it, isn't it? I can also say, I can draw a line below this. But they have very clearly mentioned it. You should draw a line in such a way that it should intersect in the sense, meet the other two sides at distinct points. If I am drawing a line parallel to this, that line should meet the other two sides at distinct points. Okay, something like this. So let's take a line DE. This is a line. In general, I've taken a line segment. You can also take a line, no issues. But let's take a line segment itself. I've drawn a line in such a way that it is meeting two sides and it is also parallel to this. Okay. If a line is drawn parallel to one side of a triangle such that it intersects the two sides, those two sides are divided in the same ratio. It's very clear, right? Observe this side, as soon as this line is drawn, this is divided. Observe this, at this point, this complete line is divided. In what ratio? AD by DB. Isn't it? Ratio is comparing. As soon as you draw the line, this is divided, right? In what ratio? What is this part AD and what is this part DB? So AD by DB. Here it will be AE by EC. These two ratios will be equal. If this line is parallel to the side, then the ratios will be equal. If the line is not parallel, see, I can also draw a line like this. Isn't it? I can also draw a line like this. Now, is this line parallel to this? Very clearly, this line and this line are not parallel, because if you extend it, they are going to meet somewhere, isn't it? If you extend it, they'll meet somewhere. So these two lines are not parallel. Now, as soon as I draw this line, this side is divided in what ratio? AD by DB. This is also divided what ratio? AE by EC, but they'll not be equal. Why? Because this line is not parallel to this. If it is parallel, then the ratios will be equal. This is the theorem BPT. Okay, a very, very simple one. Okay, let's try to prove this. Now, before proving, let's take another figure and understand it better. Okay, let's take a triangle PQR. Now, suppose I'm drawing a line parallel to PR. How do I represent it? Geometrically, I just put an arrow mark on the line, not at the ends of the line. If I put an arrow mark at the ends of the line, it means that the line keeps extending. The line can be extended. But if I put the arrow mark on the line in between, it means this line and this line are parallel to each other. Okay. So I've drawn a line. Let's take MN. So let's draw a line MN parallel to PR. Now what happens according to BPT? The two sides are divided in the same ratio. See, I've drawn a parallel to this side. So which are the two sides? PQ and QR. So observe, they are divided. QM by MP is one ratio. The other one will be QN by NR. Certain students make a small mistake, that is, while writing the ratio, they might start from here, QM by MP. For the next side, they'll start from here, RN by QN. That is wrong. If you're starting from QM by MP, for the next side also, you should start from here itself, QN by NR. Suppose you're starting from PM by MQ, corresponding RN by NQ. Okay, so this is the theorem. I've drawn a line parallel to this. Therefore, you can see this side is divided in what ratio? QM and MP, isn't it? QM and MP. Similarly, this is also divided QN and NR. The ratios will be equal if the lines are parallel. Okay, let's prove this theorem. And for state board students, this is a very important theorem which might appear in the exam for 4 marks. So let's do this. Okay, and the theorem, the first couple of steps are what? The data, what is given in the statement, and what we have to prove, and is there any necessary construction that we have to do. So the data is the given information. What is given? They have given us a triangle in which a line is parallel to one side of a triangle. So in triangle ABC, all we have got is DE parallel to BC. This is what we have got. And what should we prove? We must prove that the ratios, that is AD by DB, is equal to AE by EC, isn't it? This is what we have to prove. AD by DB is equal to AE by EC. Okay, let's make few constructions. The constructions are, let me join D and C, B and E. From D, let's draw a perpendicular to AE. Let's name it as DN. And from E, let's draw a perpendicular EL. Okay. So the construction are join DC and BE. Draw DN perpendicular to AE. Similarly, EL perpendicular to AD. Okay. So these are the first few steps. Then let's start with the proof of the theorem. So in the proof, we'll have statement and reason. So let's start. We have got in the proof, we have statement and the reason. What is the statement that I'm using and what is the reason for that statement? Okay. Now, the first step is, let's find the ratio of two triangles, areas of two triangles. That is, let's take this ADE, one which is on the top, ADE, area of triangle ADE divided by area of triangle BDE. That is, I'll trace it out. This triangle which is on the top and the other triangle here. Okay, let's find the areas of these two triangles. So area of triangle ADE by area of triangle BDE. So what is area of a triangle? Area of a triangle is given by half into base into height, isn't it? So let me write half into, for this triangle ADE, let me take AD as the base. If I take AD as the base, it's very obvious. If you want, let me draw ADE separately. ADE is like this. There is a perpendicular DN and there is a perpendicular EL. Okay. Now, I'm taking AD as the base. I can take any side as the base, right? We can take any side as the base. So let's take AD as the base. If I take AD as the base, the opposite vertex is E. From E, we have got a perpendicular line that will act as the height. Therefore, which is the height now? EL. So EL is the height. Okay. Now, similarly, for BD, half into, let me take BD as the base, into what is the height? Let me draw the triangle BDE. It is something like this, BGE. Okay. Now, if you observe, there is no perpendicular, isn't it? If I take base as BD, from the opposite vertex, you should have a perpendicular, but it is not there. But if you observe carefully, okay, it is actually a obtuse angle triangle. If you observe carefully, the perpendicular is outside the triangle. See, I've just extended the base. This is the base, extended from outside. I've drawn a perpendicular. So again, EL will be the height. So what happens? Common things, half and half, EL and EL gets cancelled. Therefore, we are left with area of triangle ADE by area of triangle BDE is equal to AD by BD. Let's take it as equation 1. Okay. A very easy one. Next, the same way, again, I'll take the triangle, area of triangle ADE itself. But at the denominator, let me take area of triangle CDE. Okay, that is this triangle CDE. CDE is this triangle. Okay. So again, the same formula, area is given by what? Half into base into height. Therefore, half. Last time I took AD as the base. Now let me take AE as the base. If AE is the base, it is very obvious. If this is the base, opposite point is D. From there, you got a perpendicular. So DN will be the height. Half. Now I'll take EC as the base. If I take EC as the base, observe this side is extended. From outside, you got a perpendicular. Again, DN will be the height. So half and half gets cancelled. DN and DN gets cancelled. We are left with area of triangle ADE by area of triangle CDE is equal to AE by EC. Equation 2. Now, if you observe properly, the thing that we have to prove is AD by DB is equal to AE by EC, isn't it? That is the proof that we have to do. If you observe, we have got it here. AD by BD is here. AE by EC is here. I have to prove this right hand side of the equation 1 and right hand side of the equation 2 are equal. If I have to prove these two are equal, it is enough if I show this LHS and this LHS. Left hand side is equal. If I prove, that is, if we prove this LHS, the left hand side, this part and this part, if these two are equal, automatically these two will become equal, isn't it? Axiom 1, things equal to same thing are equal to one another. If these are equal, then these will become equal. Now, if you observe properly, the numerators are same. You got area of triangle ADE. Here also you got area of triangle ADE. So the numerators are same. Only the denominators are different. Here you got BDE triangle. Here you got CDE triangle. If these areas are also same, then you can say this entire thing and this entire thing will be same, because numerator same, denominator same, which means this entire thing and this entire thing will become same. Now, all we have to do is somehow we have to show this triangle, area of triangle BDE and area of triangle CDE are equal. If we do that, this entire thing and this entire thing will become equal. Let's do that. Actually, area of triangle BDE is equal to area of triangle CDE. What is the reason for it? See, just like that, we cannot put up the statement. How do we know that these two are equal? Using a simple logic, that is, if you have got two triangles on the same base and between same parallel, that is, observe properly. Let's take triangle BDE and triangle CDE. This is a common side, right, for both the triangles, whether BDE or CDE. This is a common side. We call it as common base, and both the triangle are between same parallels. See, this triangle is also drawn between these two things. The other triangle is also drawn between these two things, meaning both are between the same parallels. If two triangles are on same base, and between same parallel, then they have equal areas. Then they have equal areas. So that is the reason that we got area of triangle BD is equal to area of triangle CD. Let me take it as equation 3. Therefore, from 1, 2, 3, let me write it here at the end. I don't have space, so let me write it here. From 1, 2, and 3, we can tell that AD by DB is equal to AE by EZ. What will be the reason for this? Axiom 1. Axiom 1 will be the reason. Why? Because these two things are equal. Therefore, these two things will become equal. Things equal to same thing are equal to one another. That's the axiom 1. So if you observe properly, in the numerator here, we have got AD itself. Here also in the numerator, we have got AD itself. The only thing that are different are the denominators. But actually, the denominators are also equal. How did we prove that? Because both these triangles have got same base and they are between same parallels. They have got same base and between same parallel. Therefore, they are equal in area. Therefore, the denominator become equal. Numerator also is equal. Denominator is also equal. Therefore, this LHS is equal. Therefore, I can tell RHS is equal. Now, you might ask, why? How is this? How is the even true? I mean, if they have got same base and same parallel, how can the areas be equal? It's very easy. Okay, let's understand that. Let's draw two parallels. Okay, let's take parallel lines. Now let me draw a triangle like this. Let me name it as A, B, C. Let me take another triangle D, B, C. Okay. Now let me calculate the area. Okay. Area of triangle will be half into base into height. If you observe, this BC is the base. I'll take BC as the base. Now if you observe, for triangle ABC also BC is the base. For triangle DBC also BC is the base. So half into base into height. If you observe, what is height? It is the perpendicular line drawn from the opposite vertex. Actually, if they are between the same parallel, since they are between the same parallel, the distance between the two parallels from here to here will always be same, isn't it? Therefore, the height from here to here and the height from here to here will be same, because from here to here, what is the distance? Same distance. From here to here, what is the distance? Same distance. Therefore, the height is same. I'll take it as h itself. So for both the triangles, this will be the formula. There, hence the areas will be same. Okay. So if two triangles are on same base and between same parallel, then we can say they have equal areas. Now, we can simply remember this theorem in 3 steps. Okay. The first step is equation 1. That is, we have to find the area of triangle ADE by area of triangle BDE. See, just it's a very easy thing. ADE, BDE. The second equation, area of triangle ADE itself by CDE. The third step is proving that the denominators are equal using this logic. So if you remember these 3 steps, from 1 to 3, we have proved the theorem. Okay. Now, after the theorem, there is a small concept known as corollaries of Bpt. Basically, corollary means that you are going to prove something using a result which is already proved. Okay. So that is, in Bpt, we have proved a result. That is, if a line is drawn parallel to one side of a triangle, then the other two sides are divided in same ratio. We have already proved it. Using that result, we can prove some more results. This is known as corollary. Corollary means we are going to prove something using already proven result. Okay. Now, what is the result that we have proved? We have proved that in a triangle, if a line is drawn parallel to one side of a triangle, then the other two sides are divided in same ratio. That is, using Bpt, we can say that AD by DB is equal to AE by EC, isn't it? This is using Bpt. This is the result that we have proved. Using this result, we can get few more. That is what I'll do is I'll add 1 on both sides. Adding 1 on both sides. Adding 1 on both sides. So what does it become? AD by DB plus 1, AE by EC plus 1. We can do this, right? If equals are added to equal, the result is equal. So we can do this. Okay, this 1 can also be written as 1 by 1. Similarly, this 1 can be written as 1 by 1. So let's take the LCM. So last class or in the last video when I was doing real numbers, I had given a shortcut. If not, let's do it again. How do you take the LCM? Just multiply the denominator. DB into 1, DB. This is not actually the LCM, it is the shortcut, okay? DB into 1 is DB, cross multiply. AD into 1 is AD plus DB into 1 is DB. Similarly, EC into 1, multiply the denominators. EC into 1 is EC, crisscross. AE into 1, AE, EC into 1, EC. Therefore, AD plus DB from the figure, if you observe, AD plus DB is AB. AD is this, DB is this. Add, you get entire length. AB by DB is equal to AE plus EC. AE plus EC will become AC by EC. So this was the result that was using BPT. Using this, we have proved one more result. Okay. So let me write it here. What is BPT for this figure? Okay. For this figure, BPT is AD by DB equals AE by EC. This is our first corollary. What is our first corollary that we have proved? AB by DB is equal to AC by EC. And it is very easy to remember also. Okay. These are the two sides that are divided, right? See, you have drawn parallel to this side. So the other two sides are divided. Take the full length of this side, AB, take the full length of this side, divided by, between these two parallels, you got measurements, right? DB and EC. We have to take that. So full length, AB by DB, AC by EC. We need not derive this. We can remember it like this. Okay, there is one more corollary. The second one. Okay, very simple. The same logic. But what we are going to do is, before adding one, we'll just reverse it, reciprocal it, and then add one. Okay, the same thing, reciprocal on both sides, reciprocal on both sides. Therefore, we get DB by AD is equal to EC by AE. Now let's add one, adding one on both sides. So you get DB by AD plus 1 is equal to EC by AE plus 1, isn't it? This one again can be written as 1 by 1. So let's take the LCM. AD into 1 becomes AD, crisscross, DB into 1 DB, AD into 1 AD equals AE into 1 is AE, EC into 1 EC plus AE into 1 is AE. So DB plus AD from the figure it is AB, AB by AD. EC plus AE from the figure is AC, AC by AE. Therefore, the second corollary is AB by AD is equal to AC by AE. A very, very important results. All these we are going to use. Okay. And it's very easy to remember. Take a triangle. If a line is drawn parallel to one side of a triangle, BPT is what? AD by DB, AE by AC. What is the first corollary? Take the full length of the sides that are divided. These are the sides that are divided, right? Take the full length AB, take the full length AC. AB by, between the parallels, whatever measurements you got, DB, EC. That is first. The second one is the full length AB and AC itself. For the first one, we took between the parallels. You have to take the remaining. This is what we took in the first corollary. What is the remaining? AD. So AB by AD, AC by AE. Okay. So these are the two corollaries. So along with BPT, we should also remember these two things. Okay. Now we know what is BPT. Let's also understand converse of BPT. Converse of BPT. Okay. Suppose we have got a triangle. let's say ABC, and we are drawing a line in between, okay, like this, in such a way that we have to draw in such a way that the ratio AD by DB, the ratio will be equal to AE by EC. We are drawing a line in such a way that this by this AD by DB and AE by EC are equal. So if you draw a line in such a way that this condition is satisfied, then obviously the lines will be parallel. Converse is the reverse. So what was BPT? If the lines are parallel, then the ratios are equal, isn't it? What is the converse? It is simply the reverse. If lines are parallel, ratios are equal. That is BPT. What is converse? If ratios are equal, then lines are parallel. Okay, as simple as that. So what will be the statement? A statement is important for 1 mark in the exams. So if a line is drawn parallel, if a line is drawn, if a line, or let me put it, if a line divides any two sides of a triangle, in the same ratio, then that line is parallel to the third side. So this is converse of BPT. So what does BPT tell? If the lines are parallel, ratios are equal. Converse is the reverse. If ratios are equal, lines are parallel. Lines are parallel, ratios are equal. Ratios are equal, lines are parallel. This is BPT and converse of BPT. So in the next video, we'll start with the exercise problems. Thank you, students.